Salutations, my little triglets. Welcome back to Chapter 10. Today we're doing 10.1, ellipses. Ellipses. Okay, ellipses are like a symmetrical oval, like a circle that's been squashed a little bit. So the oval could go like that, or it could be up and down. So we don't have the same radius going in every direction now. So we have to kind of tweak the circle formula to fit the different radii of the ellipse. So the basic formula for an ellipse is x squared over a squared plus y squared over b squared equals 1. So the a and b are what are going to change the radius lengths. Now, a couple of things. A and b can be switched, um, but a is always going to be the bigger of the two. Okay, so when we do little formulas and stuff with a in it, make sure a is the bigger one. Whether it's under the x or under the y, the bigger number is a. And we call that the major axis. So that means b is the smaller one, and it goes to say that it's the minor axis. Okay, so that's just some vocabulary we gotta work on. Now, when we talk about hyperbolas, that's going to change a little bit. So a memory device is to think the bigger number goes with the ellipse. So think of big happy face with big lips, and you'll remember the big ellipse. So A is the bigger number. All right, in the next section here, I want to talk about focus points. Now, these are very important. They actually are what decides how wide or how long the ellipse can be. So let's say I do have an ellipse. It was drawn by the focus points here and here. And no matter where you go, if you hit, let's say you're shooting a pool ball against the pool table that's shaped like an ellipse. If you hit here, it's going to ricochet and go to the other focus point. That's always a right angle there. So no matter where I hit it, could be over here, oops, square there, could be here, no matter where, it's going to hit that focus point. And the focus point is the letter C in any of the formulas we're going to use for the focus points. Now the plural of focus is foci. So instead of saying focus points, we could say foci. All right. And one other thing, the foci are always on the major axis. So the same axis that A is on. Okay. Another name for the A points is the vertices. Okay, they're on the major axis. For B points, they don't have a special name. They're just called endpoints of the minor axis. And C is the foci. So, let's label a few things here. So from here to here, that length is A. From here to here, that length is B. And from here to here, that length is C. So it's from the center to the endpoints or to the focus points. It's not all the way across. Okay, so from center to the endpoint on the major axis, that would be A. From center to endpoint on the minor, that's B. From center to the focus point, that's C. All right, let's try a few of these now that we've got all the lingo down. So let's say I have x squared over 9 plus y squared over 4 equals 1. First of all, which one's A? Technically it's a squared. It's the bigger one, so that's 9. So A is plus or minus 3. So we're going to go to the right 3 and to the left 3 because it's on the x-axis. And then B squared is 4. That means B is plus or minus 2. So that's going to be up 2 and down 2. So let's draw a quick sketch. Over 3, up 2, put the endpoints on there, and then you can draw your ellipse. And what if I want to find the focus points? Find the foci. You use the formula a squared minus b squared equals c squared. It kind of looks like the Pythagorean theorem, but it's not. It's got the minus in there. So let's plug in a squared and b squared. So 5 equals c squared. That means c is plus or minus 5. And remember, c is always on the major axis, so it's on the one that you plotted a. So it's going to be, whoops, this should be square root of 5. So square root of 5 is about 2 point something. So if I plot those, it's going to be right in here somewhere. So the focus points should be on the inside of the ellipse. You don't really need them to graph because we can do it with A and B, but it's good to know where they are. All right, let's try this one. 25x squared plus 16y squared equals 400. Now that doesn't look like the original ellipse formula because on the right it should equal 1. Well, if we want to make 400 equal 1, the only way to do that is to divide by 400. So let's do that to all of them. And we end up with x squared over 16 plus y squared over 25 equals 1. Now it looks a lot more like what we're used to. All right, this time a squared is 25, so a is plus or minus 5, but it's under the y. So my points are 0, 5, and 0, negative 5 that I'm going to plot. B squared is 16, so b is plus or minus, 4. So that'd be, let's get rid of that, plus or minus 4, so that would be on the x. So 4, 0, and negative 4, 0. If I wanted to find c, I take a squared minus b squared equals c squared, so 9. So c equals plus or minus 3. And it's the same as the a, so I can write it as 0 and plus or minus 3. Graphing this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 4, draw the ellipse, and then label our focus points. Okay, so pretty standard. All right, let's try one that's off center. Okay, it's not on 0, 0. Let's say the center is at 1, negative 2. Okay, so that means, let's say I have x squared, well, back up here a second. Whoops, not that far. All right, let's say our original equation was x squared over 3 plus y squared over 5 equals 1. So what we need to do is add this number to the points. So if I were to plug it in, it would be x minus 1 squared over 3 and y plus 2 squared over 5. Kind of just like the circle, this is h and this is k. All right, just like the circle. Now what we have to do is we need to add to the normal points. Okay, normally if it's centered on the origin, our points would be, well, a squared is 5, so a would be plus or minus root 5. B squared is 3, so b is plus or minus root 3. So my points, because a is under the y, would be 0 and plus or minus root 5. And that b is under the x, so it would be plus or minus root 3, 0. Now what I have to do is take this and add it to each of those. So we have to kind of separate it in our brain a little bit. So if I take 1 and add it to 0, I get 1. Then if I take negative 2 and add it to the positive root 5, I get negative 2 plus root 5. I can't really change that. Then I do with the minus. So again, I take the 1 with the 0 is still 1. And then I have minus 2 with the minus root 5. Minus 2 minus root 5. So those would be the 2 points on the y. Okay, so then we look at the x. We've got b equals plus or minus 3. So we're going to take this, let's do it in blue this time. Let's do this, and we're going to add it, whoops, over here to that. So 1 added to root 3 would be 1 plus root 3. The negative 2 added to 0 is negative 2. Then we have 1 added to minus root 3, and the negative 2 added there. Okay, so next, if we want to find the focus points, c. So remember, a squared minus b squared equals c squared. Here's our a squared, here's our b squared. So 5 minus 3 equals 2. So c squared is 2, that means c is plus or minus root 2. So again, we have to add the 1, negative 2 to our c points. Now c is the same as a, so it's 0 and plus or minus root 2. But if we're adding the 1 and negative 2 to this, we're going to end up with 0 plus 1 for both of those, and then root 2 and a negative 2 would be root 2 minus 2, and then negative root 2 minus 2. So, whew, that's a lot of work. Sometimes it comes out radicals, sometimes it comes out normal numbers. So, you just got to work with it and just add the center to the normal points that you normally would find. Okay, I'm going to do one in class about completing the square. It's a lot like what you did with a circle, but there's a little twist in it because of the extra numbers on the bottom here. It changes just a little bit. But we'll do that in class. All right, ta-ta for now.